Hello, Algebra 2 students. I wanted to take a little bit more time to do some examples of completing the square. Many of you saw this in Algebra 1 extensively, and so you know it. Some students I have learned did not have much guidance with this in Algebra 1 or in prior courses. So I'm doing this video for those that need a little bit of extra help, and I'll go a little slower through the material. Okay, so for the beginning here, we are looking at completing the square of a quadratic. Completing the square of a quadratic when the leading coefficient is 1. And so throughout this video, I'm going to be referring to a, meaning the coefficient in front of x squared, and I'm going to be referring to b, meaning the coefficient in front of x. Now, you might be able to just look at this at sight and say, well, if I just take 10 and I divide by 2, that's 5. And if I square 5 and I put 25 here, that creates a perfect square trinomial, and you'd be correct. And so what you end up doing is you end up taking the b term, you divide by 2, and you square it. So you end up with 5 squared, which is 25. And that allows us to have a perfect square trinomial, which is x plus 5 squared. Let's look at the next one. I need this to be, 49. And how do I get that? I take the b term. I first note that the leading coefficient is 1. I take the b term 14, divide by 2, and square it. That's 7 squared, which is 49. And then it's a perfect square. And by the way, the number that goes here is always the number that's inside the parentheses here. It works out every time. Works just the same when it's negative. Negative 20 divided by 2 squared gives me negative 10 squared is positive 100. Positive 100 goes here, and now I have a perfect square, and it is x. Now the number that's in here is negative 10, and that's what goes over here. X minus 10 squared works every time. Okay, so how do we use completing the square to solve equations? So let's look at that. If you have an equation where you have a quadratic, that's a quadratic polynomial expression, and it's an equation because I've set this equal to 0. If you're solving a quadratic equation where you've got everything on one side and it's equal to 0, you can complete the square to solve it. Let's do it. X squared plus 10x. And the first thing you want to do is you want to subtract 7 to move the constant to the other side. Now, a little bit of side work. We take the b term, the 10, you divide by 2, and you square it. That's 5 squared, so that's 25. Okay, so that means you add 25 to the left-hand side, and you add 25 to the right-hand side. You can also add and subtract 25 from the same side on the left, and that's equivalent. What's great is the left-hand side is now x plus 5 squared, and the right-hand side is, 18. And you can take the square root of both sides to get rid of the square on the left. Got to remember we're solving an equation, so we need plus or minus, and that radical simplifies. Plus or minus 18 is 9 times 2, so if 9 comes out, it becomes 3 root 2. Subtract 5 from both sides, and I get x equals negative 5 plus or minus 3 root 2. So we have found two solutions. We have found the solutions x equals negative 5 plus 3 root 2, and x equals negative 5 minus 3 root 2. We have found two solutions to our original quadratic. These two numbers make that equation true. And you'll notice that our answers are irrational because there is a square root of 2. When your solutions to a quadratic equation are irrational and you get square roots, that means that the original quadratic did not factor. So it was not a factorable quadratic to begin with. So let's look at one more example here. And okay, so we've got x squared minus 20x equals negative 140. And I'm going to rewrite this with a little bit more space. And I will take negative 20 and divide that by 2 and square it. And that's going to equal 100. So 100 is what I need to add to the left-hand side. And then I subtract that off so that the left-hand side and right-hand side are equal. I equivalently could have added 100 to the other side of the equation. Both are valid. We're going to see in a bit why we need both techniques. So what do we get over here? Well, this is a perfect square. So that's x minus 10 squared. And reminder, the number that goes here, including the sign, negative, is always what you get inside the parentheses when you do that little side work. And the side work is always the b term divided by 2 squared, where that's b. Okay, so that's your completing the square shortcut. And what do we have here? Negative 100 equals negative 140. And I'll clean up that little arrow there. And we have x minus 10 squared equals, now we got to add 100 to both sides, negative 40. So because I have a negative on the right-hand side, the solutions here are not going to be real. They're going to be non-real complex numbers. Square root of both sides, plus or minus the square root of negative 40. X equals positive 10, add 10 to both sides, plus or minus the square root of negative 40. And negative 40 is, well, definitely an I can come out. And square root of 40 is 2 times the square root of 10. And so we get 2i square root of 10. The minus gives us the I out. I can break 40 up into 4 times 10. Square root of 4 is 2, so a 2 comes out, and I comes out, and I'm left with 10 underneath, which I cannot simplify. And I'll just leave the solutions in this compact form with a plus or minus. Okay. Sorry about that low battery symbol. Okay, now, this example, I forgot to erase this. I want to go through this. I did it in class, but I want to explain it again more slowly. Let's do this. So, let's say I want to solve this equation, or let's say I actually want to complete the square of this quadratic in general. We actually need to do it in general. For example, sometimes when we're given a function that looks like this, so it's a quadratic function, we actually want to complete the square without solving any quadratic equation. And the way we do that is exactly what we've been doing so far. So we have y equals, except there's one extra step, an important extra step. You remember, everything we've done so far had a leading coefficient of 1 in front of this x squared, but now there's a 2. So first things first, we need to factor that 2 out. And what I recommend is just factoring the 2 out of the 2 terms with x. So factor out of the x squared term and out of the x. And watch, what's left is x squared plus 6x. And I left the 28 on the outside. Okay. Now, rewrite this, x squared plus 6x with some space plus 28. Now I left space to add and subtract a number. Now what we want to do, so just to write down my steps here, factor out the leading coefficient. I'll abbreviate coefficient. Now, complete the square. Add and subtract b over 2 squared. And let's do that on the inside. We will add, well, 6 divided by 2 is 3. 3 squared is 9. So we're going to add 9 and subtract 9. Notice I did it on the inside of the parentheses because I want this equation on this line to be equivalent to the equation on the prior line. So if I add 9 inside the parentheses, I need to subtract 9. So I'm actually adding 0, and I'm not changing the equation. I'm not changing the expression on the right-hand side. Okay, now here is the non-obvious step, and that is this. Distribute the 2 to the minus 9, the second 9 that we subtracted. Distribute the 2 to only that to get it out of the parentheses. 2x squared plus 6x plus 9. But what's going to come out of the parentheses is minus 18 plus 28. So let me just make that red to clarify. That's what we did there. So distribute the 2. Okay, so we cleaned things up to now. What's inside the parentheses is now a perfect square. So this is x plus 3 squared. And on the outside, let's see, we have plus 10. Okay. We're actually done. We've completed the square of this quadratic. Now there's 2 applications to this. This is a little preview of what's coming in a future section. If I write this quadratic this way, a quadratic graph will have a quadratic graph either goes this way or it goes this way, depending if the leading coefficient is negative or positive. And the vertex of the parabola is the point that's at the bottom or the top of the 2 examples I've seen here. Since this is a positive leading coefficient, it's going to look like this one. And the vertex, you can get the vertex from this. It'll be the opposite sign of this, so it'll be negative 3 and 10. You might remember when we did our graph transformations that this is a transformation of the x squared graph, 3 to the left and 10 up. And so what we'll get is 3 to the left, and I'll just put 10 here, so I'll put negative 3. So this quadratic is going to have a vertex at negative 3, 10. And it's going to be stretched vertically to be a little bit taller than a standard quadratic. So this graph will look like this, and the vertex is negative 3, 10. So completing the square of a quadratic allows us to get it in a better form for graphing. And this is called the vertex form. It also allows us to solve a quadratic equation if we set y equal to 0. And sometimes it'll be complex solutions, sometimes it will be real solutions. Okay, so last one. If we have, let me just give you an example that's a little bit more involved, and it just has a fraction, and there's a couple ways you can handle this. I said you should factor it out of the first 2 terms, and you absolutely can. You could also just multiply both sides by something that cancels away that fraction. Both work. So if our choice was to factor this out, we would factor out a 2/3 x squared plus, now I'll leave some space, plus 1. Now, if I factor a negative 2/3 out of 8x, then this plus is going to change to a minus. And then side work. Whatever I put here, it's going to be question mark x. Whatever I put there times negative 2/3 needs to equal 8. So if I just solve for this, I would get that the question mark is 3 times 8 is 24. 24 divided by 2 is 12, and it's negative. So this would be negative 12. And you can check that 2/3 times 12 equals 8, because 2 times 12 is 24. 24 divided by 3 is 8, and the minus times the minus gives you the plus. Okay, so we've got that. We now need to complete the square by taking the 12 and dividing by 2 and squaring it. So 12 divided by 2 is 6. 6 squared is 36. But we need to subtract 36 as well on the inside. We now need to distribute the negative 2/3 to the 36. And we get negative 2/3. And I'm going to keep the x squared minus 12x plus 36 on the inside. But on the outside, I'm going to multiply 2/3 times 36. Well, 36 divided by 3 is 12. 12 times 2 is 24. Negative times a negative is a positive. So this would be positive 24. 2/3 of 36. Positive. Okay, so I got this. By the way, there's still, I forgot to write 0, 0, 0 on the left-hand side. And so I have 0 equals negative 2/3 x minus 6 squared plus 25. And now I just subtract the 25. Multiply both sides by 3/2. Multiply both sides by negative 3/2 and negative 3/2. The 3's will cancel. So this will cause the 3's to cancel, the 2's to cancel, the negative is a positive. So on the right-hand side, I'm left with x minus 6 squared. On the left-hand side, I'm left with 75 over 2. Square root both sides, plus or minus square root of 75 over 2 equals x minus, equals x minus 6. And add 6 to both sides, and I get x equals 6 plus or minus, well, I'll just do it in 2 steps. Square root of 75 over 2. And, yeah, got plenty of space here. And then x equals 6 plus or minus. Now, the factor of 25 is in 75, so a 5 is going to come out. 5 square root of 3 over 2. But I can also write that as square root of 3 over square root of 2. Multiply top and bottom by the square root of 2 to rationalize the denominator. 6 plus or minus, sorry, that's a 5. 5 root 6 over 2. All right, those are my 2 solutions. Okay, that was a little bit more of an advanced problem. My master level problem is this one, so you should give it a try. On a follow-up, well, I'll have them in my notes. On a follow-up video, I can do this one. And on a follow-up video, I will do this one where A, B, and C are unknown, and we solve it in general. All right. See you in another video.